Hello students, let us start today this complex compounds or coordination compounds. Complex compounds or coordination compounds. Before going to start up this particular lesson, let us have a good idea about what are this particular simple salt, double salt and complex compound. Simple salt, double salt and complex compound. Let me take first what is a simple salt. What is a simple salt? Next, double salt. Double salt. Simple salt, double salt. Let me take again complex compound. Complex compound. Simple salt, double salt, and complex compound. The salt which is actually the salt which is carrying a distinguished cation and distinguished anion is said to be a salt. Said to be a salt. A salt which is carrying a distinguished cation and distinguished anion is said to be a salt. What is simple one? It is carrying only one type of cation and one type of anion. That is very simple. Therefore, it can be also called as what a simple salt. Coming to this particular double salt. Generally, by the combination of two or more than two simple salts, you are getting a double salt. Combination of two or more than two simple salts, you are getting a double salt. But we cannot say in this way this particular definition of a double salt. The definition of a double salt we can define in a different way. What is this particular double salt? The salt which undergoes complete ionization in aqueous solution produce all of its component ions. All of its component ions. Let me show one or two examples. Let us consider the first example, cornellite. Consider this particular cornellite. It is nothing but what? KCl, MgCl2, 6H2O. Cornellite, KCl, MgCl2, 6H2O. Once you are putting into water, once you are putting into aqueous solvent like water, it is completely ionizing to produce K plus, Mg plus 2 and 3Cl minus ions. 3Cl minus ion. What I said? The salt which undergoes complete ionization produce all of the component ions, and the component ions are exhibiting their specific chemical tests. Okay. K plus ion is independent, it is exhibiting its independent properties. Mg plus 2 is actually independent, exhibiting its independent properties, and Cl minus ions also similarly. So the salt which undergoes complete ionization in aqueous solution producing all of its component ions, all the component ions exhibiting their specific properties, their independent properties, such as salt what we call this particular double salt. Let me give another example which is a suitable and good example. Let me take potash alum. You take, well known to you, potash alum. Potash alum you take, then this is what, nothing but you know well, K2 SO4 Al2 SO4 taken thrice and 24H2O. It is the what? Potash alum. This particular potash alum, again you are putting into water, it is undergoing complete ionization. What way it is undergoing ionization? Check it. 2K plus and you are getting what? 2Al plus 3. How many sulfate ions? 4 SO4 minus 2 ions you are getting. Like this, K plus ions, Al plus 2 ions and sulfate ions you are getting. This is also undergoing complete ionization in aqueous solution, producing all the component ions, and all these component ions exhibiting their independent or specific chemical properties because they are free in the solution. So the salt which undergoes complete ionization produce all the component ions, and all the component ions exhibiting their independent properties, such salt what we call double salt. Let us come to next complex compound. Next complex compound. Now you consider what is complex compound. The salt or the compound which undergoes partial ionization, that is what complex ion does not ionize, such what we call complex compound. Let me give a simple example. Let us consider potassium ferrocyanide. Let me take FeCN taken 6. This you are putting into water, then what you are getting? See, it is undergoing partial ionization. I said 4K plus and FeCN taken 6. FeCN taken 6 minus 4. Look at here. the salt or the compound which undergoing partial ionization. It is only undergoing the K plus ions are ionized, and the bracket part, that is what you call complex ion, undergoing partial ionization. The complex part is whatever the weight in the solid state, similar way in the aqueous solution. The complex part is, the bracket part is not ionized, therefore undergoing partial ionization, and the complex ion is not ionizing. The complex ion is actually exhibiting its independent property as such. It is actually showing specific properties of complex ion, but is not exhibiting any property of Fe plus 2 or Cn minus ion. So the compound or the salt which are undergoing partial ionization, that the complex ion does not ionize, is known as what complex compound. Undergoing complete ionization, undergoing partial ionization means the complex ion does not ionize. We call it as what complex compound. A simple salt, a double salt, and a complex compound. This is the what the three definitions of simple salt, double salt, and complex compound. Next, let us see what are the parts of a complex compound. Let me show. See, parts of the complex compound, different parts are there in the particular complex compound. Look at here, K4, FeCN taken 6, FeCN taken 6, we consider a simple complex. This particular part what we call ionization sphere. This is ionization sphere, we can call ionization sphere. And this particular part what we can call coordination sphere. This is coordination sphere. Ionization sphere, and this is what coordination sphere. This particular we can call it what central metal ion. This particular we can call coordination number. This we can call it as what ligand. See, these are the parts of a complex compound: ionization sphere, coordination sphere, and this is what the central metal ion, and this is what the coordination number. This is what the ligand. These are actually parts of this particular complex compound. Next, let us see what are the terms used in complex compound. The important term we use in complex compound is ligand. Ligands are very important. I will give few ligands, but each ligand, its name, its structure, its density, its charge, and how this particular ligand is abbreviated in a complex. All the information about this particular ligand is very important. Whatever the ligands I am giving now, you should remember all these: name of the ligand, structure of the ligand, and charge of the ligand, density of the ligand, and how this particular ligand is represented or shown in a particular complex. These are all the information about ligand is important. Few ligands let us discuss: monodentate, bidentate, tridentate, tetradentate, and pentadentate, hexadentate. Like this ligands discussion. Now I show the discussion of ligands. Terms used in complex compound. Terms used in complex compound. The first important term what I said is ligand. A molecule or ion which is capable of donating a pair of electron. We call it as what ligand. Now we consider this particular NS3 is carrying a pair of electron. It can easily donate a pair of electron to this particular. Then molecular ion which is capable of donating a pair of electron. We call it as what ligand. Next, a ligand molecule may carry one donor atom or more than one donor atoms. Now we consider it is actually amine ligand is carrying only one donor atom. This is only what monodentate. There may be ligands with more than one donor atom. That means the bidentate, tridentate. Let us see now ethylene diamine. Let me write ethylene diamine. Ethylene diamine, it is actually donating two donor atoms. It is carrying what two donor atoms, En or ethylene diamine. We call it as ethylene diamine. Next you take diene, diethylene, triamine, diethylene, diethylene, triamine. It is carrying what? 3 donor atoms. 3 donor atoms. Like this, based on the number of donor atoms, first donor, second donor, third donor, like this, it is considered what? A tridentate. Monodentate and bidentate. It is carrying 3 donors, tridentate. Let me give one more example. Oxalato ligand also I will give oxalato ligand C2O4 minus 2. The structure of this particular ligand is what? C single bond O and actually charges, and followed by this is the structure of oxalato ligand. This particular oxalato ligand, it is considered, it may be any metal ion like platinum. Let us consider, for example, it is linked through 2 donor atom, carrying 1 donor monodentate, carrying 2 donors bidentate, carrying 3 donors, it is what? Tridentate. It is also carrying 2 donors, we can call it what? Bidentate. Like this, based on the number of donor atoms, the ligands are classified into mono, bi, tri, tetra, penta and hexadentate ligands. This is amine ligand. Ammonia, we call it what? Amine. This is what? Amine ligand. This is what? Ethylene diamine, EN we say. It is diene. Diene means what? Diethylene, triamine. This is what? Oxalato ligand. Now, you are clearly looking on the board, this particular first 3 ligands, look here, amine ligand, ethylene diamine and diene. These particular 3 ligands are actually neutral ligands. These are neutral ligands. But to consider this particular oxalato ligand, clearly observing it is what? Carrying 2 negative charges. It is what? Negative ligand. So, some of the ligands are neutral, some of the ligands are actually negative, and some are found to be positive. Based on this particular charge and density, ligands are actually classified into different types. Now in a tabular form I will show what are the different types of ligands. What I am saying, ligands is actually important, each ligand, its structure, density, charge, and how this particular ligand is shown in a complex, how it is abbreviated in the complex, that is important. I will give in the tabular form some of the ligands which are important. Classification of ligands based on charge and density. Classification of ligands based on charge and density. Classification of ligands based on charge and density. Let me make a table. We classify different types of ligands based on this particular table. First one, let me see nature of the ligand. Second one, structure of the ligand. Nature of the ligand, structure of the ligand, and abbreviation of the ligand. Abbreviation, how it is abbreviated. Abbreviation of the ligand. It is what? Nature of the ligand and structure of the ligand, abbreviation used in the complex. Now let us consider first one. Monodentate negative. Monodentate negative ligand. First type, let us take monodentate negative ligands. It is very simple. Let me say it is actually fluoro, chloro, bromo. Let us write first one fluoro, chloro, bromo, iodo. Fluoro, chloro, bromo, iodo. Nature of the ligand monodentate negative, fluoro, chloro, bromo. Let us iodo. This particular structure which is simply we represent by F minus and Cl minus, and it is Br minus and I minus. So nature of the ligand monodentate negative, fluoro, chloro, bromo, iodo. These are actually represented by F minus, Cl minus, Br minus, I minus. Simply their abbreviation is also simple, fluoro, chloro, bromo, iodo. This is what abbreviation of this particular fluoro, chloro, bromo, iodo. Next let us consider cyano. Cyano, you can say it is what simply Cn minus, it is what Cn. Isocyanone, it is actually what Nc minus, it is what Nc. Nc minus Nc, isocyanone. Next cyanato, we can consider simply OCN. OCN minus is what cyanato, it is what OCN. Isocyanate, ONC minus, these are ONC minus. Like this, fluorochlorobromido, cyano, isocyanone, and again cyanato, isocyanate. These are some of the monodentate negative ligands. Some more are there. Let me continue this particular. Some more monodentate ligands, negative monodentate. Next you can take thiocyanato, it is what SCN minus, and we can represent simply SCN. Isothiocyanato, we can write as what NCS minus, it is what NCS minus. Like this, these are actually monodentate and negative ligands. In the same monodentate, neutral ligands are there. Let me show some of the monodentate neutral ligands. Now monodentate neutral. Under monodentate neutral, let us take amine. Amine, simply it is what NS3, and it is also shown as NS3 in the complex. Second one, aqua ligand. Aqua is nothing but what H2O. Then it is actually simply shown by what H2O. Amine, NS3, aqua, H2O. Next let me write carbonyl. Carbonyl ligand, it is actually CO, represented as what simply CO. Carbonyl and triphenylphosphine, we can say it is what PPH3. PPH3, it is what triphenylphosphine. It is represented as what simply PPH3, triphenylphosphine. And you can take pyridine. Pyridine, it is simply, we can write as what pyridine, you know well, it is simply pyridine, and you can represent this actually either PY, or you can say C5H5N, either way you can represent. These are amine, aqua, carbonyl, triphenylphosphine, and again pyridine. These are some of the neutral monodentate ligands. And again monodentate positive ligands also there. Let me show monodentate positive ligands. Consider it is what nitronium. Nitronium, it is what simply NO2 plus. NO2 plus, it is actually NO2. And nitrosyl or nitrosodium. Nitrosyl we can say, or we can also call it what nitrosonium. Nitrosyl or nitrosonium. Nitrosyl or nitrosonium, NO plus, it is what represented by NO. The next one, hydrazinium. Hydrazinium, this is what hydrazinium, it is NH2 NH3 plus. NH2 NH3 plus, it is represented as what NH2 NH3. So these are what the monodentate positive ligand. Some are monodentate negative I given, and few I given monodentate neutral. These are what monodentate positive. Next let us see bidentate ligands. Next after monodentate, let us consider some of the bidentate ligands. Bidentate negative ligands. Bidentate negative ligands. Bidentate negative. Bidentate under negative ligands, you consider the first one, carbonato. Let us say carbonato ligand. It is simply what say, this is the structure we are writing, carbonato ligand. It is represented as what simply CO3. The charge over the each ligand is important. Let me write this particular formula with a charge here, carbonato CO3 minus 2. You can also take the next one, sulfato ligand. Sulfato, you can write as what? SO4 minus 2. This particular ligand is actually bidentate and negative ligand, sulfato ligand. Sulfato ligand. Next we take oxalato ligand. Oxalato ligand, it is what? C2O4 minus 2. The structure, it is what? Like this structure of this particular ligand, oxalato ligand. This is C2O4 oxalato ligand. So it is what? Carbonato, sulfato, oxalato, many are there in this. I will show few more this bidentate negative ligands. Wait, some more ligands. Let me write negative ligands. Negative bidentate. Glycinato. Glycinato, GLY, glycinato, GLY minus, single minus is carrying. What is the structure of this particular glycinato? It is what? NH2, C double bond O minus, glycinato ligand. It is abbreviated as what? GLY, glycinato. Next, dimethyl glyoxymato. Dimethyl glyoxymato, let me say it is DMG minus, dimethyl glyoxymato. The structure of this particular dimethyl glyoxymato, this is the structure of the ligand. Structure of the ligand, these are what donor atoms in particular. This dimethyl glyoxymato, it is represented by what? DMG. Dimethyl glyoxymato represented by what? DMG. Next, 8-hydroxyquinolinol. 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 This is commonly represented as what? Oxygen, single minus. Each ligand, the charge of the ligand is important. DMG is carrying single negative charge and oxygen is carrying single negative charge. The structure of this particular oxygen. Oxygen, it is simply represented as what? Oxygen. So like this, dimethyl glyoxymato and 8-hydroxyquinolinol represented as what? Oxygen. Next one, acetyl acetonato. Acetyl acetonato. Acetyl acetonato. See, this is what? ACAC minus. ACAC minus. The structure of this particular ligand is important to remember. C single bond O, double bond CH, C double bond O, CH3. This is what? ACAC. Like this, some of the important negative bidentate ligands. Negative bidentate ligands. Let me introduce again bidentate neutral ligands. Bidentate neutral ligands. Bidentate neutral. The best example under this word, ethylene diamine, well known to you, the famous ligand ethylene diamine. Ethylene diamine, the structure of this particular ligand is, this is ethylene diamine. It is simply represented as EN. EN stands for ethylene diamine. Next, propylene diamine. Propylene diamine. Propylene diamine. It is also known as 1,2-diaminopropane. See it, both are one and same. 1,2-diaminopropane. 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 It is propane, but 1,2 position carrying what? Amine groups. It is 1,2-diaminopropane. It is represented as what? PN. Ethylene diamine and again propylene diamine. Next one, trimethylene diamine. Trimethylene diamine. Trimethylene diamine. Trimethylene diamine is also known as, is also considered what? 1,3 1,3-diaminopropane, 1,3-diaminopropane, 1,3-diaminopropane. This is nothing but in the 1,3 positions amine groups are there. Amine groups are there. 1,3-diaminopropane. It is what NH2 and NH2. See the difference between PN and DN. It is 1,2-diaminopropane. It is 1,3-diaminopropane. That is in 1,2 positions. It is in 1,3 positions. This is considered as what TN. EN, PN, TN. These are what bidentate. Bidentate neutral ligand. Bipyridyl you can consider. Bipyridyl is famous ligand again. Bipyridyl. Bipyridyl you can take two pyridine rings fused together like this. It is the bipyridyl. Bipyridyl. This is actually represented as what bi-pi. This is represented as what bi-pi, bipyridyl ligand. Bipyridyl bi-pi. Next you can take it is orthophenanthrolane, 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 or you can also call it as what 1,10-phenanthrolane, 1,10-phenanthrolane, orthophenanthrolane, or you can take it as what 1,10-phenanthrolane, orthophenanthrolane or 1,10-phenanthrolane. See the structure of this particular ligand. Orthophenanthrolane or 1,10-phenanthrolane. This is 1,10 of phenanthrolane, orthophenanthrolane. It is generally represented as what OPhen, orthophen, orthophenanthrolane represented as what OPhen. These are some of the bidentate neutral ligand.